1033, Chapter 4, Section 1, Systems of Equations. This is Part 1. So there's going to be 2 videos for this section because it has a lot of material. First one is that where we see if an ordered pair is a solution for a system. This is example 1 in your book. This says negative x plus y equals 2 and 2x minus y equals negative 3. And it wants to check to see if negative 1 is a solution for this system. Now, in order for it to be a solution for the system, it has to work for both equations, not one. So what we do is we know that negative 1 is x, 1 is y. So we put the negative 1 in for the x, the 1 in for the y for the first equation. We get negative 1 plus 1 equals 2, which gives us 2 equals 2, so it's okay there. We stick negative 1 into the second equation. We get 2 times negative 1 minus 1 equals negative 3. We get negative 3 equals negative 3. Because it works for both equations, yes, it is a solution for the system. We go to the second part to this one. We have 5x plus 3y equals negative 1. X minus y equals 1. And we want to see if negative 2, 3 is a solution for this system. Remember, this is a system of 2 equations. Plug the negative 2 in for 5, the 3 in for y. Solve, we get negative 1 equals negative 1. Okay, so far. Plug the negative 2 in for the x in the second equation, 3 in for the y. We get negative 5 equals 1. Doesn't work. Must be the same number on both sides. So negative 2, 3 is not a solution for the system for 5x plus 3y equals negative 1, x minus y equals 1. Next we come to solving systems by graphing. Now, what happens here is that we're going to graph the 2 equations, put them in. What we're going to do on these type of problems is the first thing we're going to do is we're going to put each equation in the system in the slope-intercept form and graph it. You can see here that we change the x plus y equals 2 to y equals negative x plus 2 by subtracting the x over. If we start with 2, we go up 1 over 1. The red line represents that equation. Here we're subtracting the 3x over, then multiplying by negative 1. So we get y equals 3x plus 2. Again, we're doing it 2. Okay. And in terms of this one, we go up 2 and over 1. Here's the equation here. I'm sorry. Negative x plus 1 was the blue line, and y equals 3x plus 2 is the red line. Where they intersect is at 0, 2. So the intersection of 2 lines is a solution for the system of those 2 lines or those 2 equations. In our second example here, we have x minus 2y equals 4, and x equals 2y. So again, the first thing we're going to do is we're going to change both equations into slope-intercept form. X minus 2y equals 4 becomes y equals 1 half x minus 2. X equals 2y becomes y equals 1 half x plus 0. Right away, if you notice the equations in slope-intercept form, they have the same slope. And we've already learned from a previous section that when the equations have the same slope, they're parallel. So when lines are parallel, they can't ever intersect, so there's no solution. So remember, parallel lines will have the same slope, but different y-intercepts. That means there's no solution for the system. Okay, third example. We have the equation 2x plus 4y equals 10. When we put it in slope-intercept form, we get y equals negative 1 half x plus 5 halves. We get x plus 2y equals 5. When we put it in slope-intercept form, we get y equals negative 1 half x plus 5 halves. You can see that they have the same slope and the same y-intercept. So they're the same lines. So there's infinite solutions. So if we look at a system of 2 equations only, there's only 3 possibilities. 1, where we have one solution. That means the 2 lines intersect at a certain point. 2, that there's no solution. That means the lines are parallel to each other. That means the slopes are the same, but the y-intercepts are different. 3, where there's infinite solutions. So where both equations are the same line because they have the same slope and the same y-intercept.